Hello, I'm Mr. Goan and welcome to my National 5 Relationships Outcome 1.5 video. Now, on request from some of you, I've upped the frames per second on the recording, so this should be a better recording this time. Now, Relationships 1.5 looks at sketching trig graphs, the period of a trig graph, and solving trig equations. It's worth a total of 6 marks, so it's 3 out of 6 to pass this one. Only 3 questions, and we'll jump straight in. So, question 17. Sketch the graph of y equals 5 sine x for 0, which is less than or equal to x, which is less than or equal to 360 degrees. Now, it is always good to draw our axes in first, and you should use a ruler for this. So I'll draw in my axes. Now, the way that I like to do this, because the graph won't really change shape at this stage, we can mark on our axes y and x. And I like to mark on our 360, and then for my scale I'm going to half this and say 180 is here, and I'm going to put a mark for 90 and a mark for 270, and I'm going to put a mark for my maximum and a mark for my minimum. I don't yet have values for them, but we will take those in a moment. I will mark on 0 though. Now, straight away looking at this, we've got y equals 5 sine x, so we're going to look at the sine x bit. Now, sine x, we know the shape of that graph. We know it normally goes like that. It's a nice wee wave, starts at 0, up to its maximum, back to 0, down to its minimum, back to 0 again. So we can mark that on our graph. We've got 0, at the 90 mark it's up at its max, at 180 it's back to 0, at 270 it's down at its minimum, and at 360 it's back to 0. And nice and neat, we can draw in that shape, because like I said, the shape of y equals sine x won't change. The last thing we need to take note of here is the 5 in the front of our equation there, in the front of our graph. That tells us that our maximum has been multiplied by 5, as has our minimum, which makes sense. If sine of 90 is 1, then 5 times the sine of 90 is going to be 5. Our minimum is negative 5. And there's our graph sketched on with our maximum, our minimum, and our increments marked onto our x-axis. 2 marks for that one. And moving on. Write down the period of the graph of the equation y equals cos 4x. Well, the period is how many waves we get inside 360 degrees, and it is the number here in front of that x. So the period is going to be 360 divided by the number in front of that x there. So our period is going to be 360 divided by, and in this case it's 4. And 360 divided by 4 is 90 degrees. Only 1 mark for that one, so we won't linger on it. Question 19. Solve the equation 7 cos x minus 3 is equal to 0, for 0 is less than or equal to x, which is less than or equal to 360. So we've got 7 cos x minus 3 equals 0. Now, rearranging these using our normal rules for solving equations, we're going to add 3 to both sides, giving us that 7 cos x equals 3. Then we're going to get rid of this 7 by dividing both sides by 7. Gives us that cos x is equal to 3 over 7. So x is going to equal the cos to the minus 1, the inverse cos of 3 over 7. X is going to equal then, we use our calculators for this one, second function cos gives us cos to the minus 1, open our bracket, 3 divided by 7, close our bracket, equals, and we get 64.62 ... which we're going to round that to 64.6 degrees. However, we're not done yet, because we know that the graph of cos looks like that. So at cos x equals 3/7, well, we're going to have 2 answers there, aren't we? So we need to look at our cast diagram. So all students take cake. We know that this is cos x equals a positive number, so it's positive in the all quadrant and positive in the cos quadrant. So we have our first one here, 64.6. In the cos quadrant, that gives us x equals 360 minus 64.6. which gives us a second answer here of 295.4 degrees. And that's both of our values of x for the equation 7 cos x minus 3 equals 0, when we consider the graph between 0 and 360. Good luck!